This video will cover standard MCC 8.G.1, transformations. Learning target. The essential question, what are transformations? i.e., translation, reflection, rotation, and dilation. Today, we will define 4 types of transformations because it will allow you to correctly identify what transformation is being performed and also allow you to label the pre-image and corresponding image correctly. So by the end of this lesson, you should be able to, in your own words, define the different types of transformations without assistance from your notes. Okay, what is a transformation? Some may think that a transformation is when a magician takes one object and magically changes it into a different object. Or some people may have said, Transformers? Well, both of those in this case, they're wrong. Transformations are changes in positions of a point or figure on a coordinate plane. For our discussion, we're going to talk about 4 different types of transformations: translations, reflections, rotations, and dilations. We're going to start off with translations. In a translation, every point of the pre-image is moved the same distance and in the same direction to form the image. It is also known as a slide. So let's take a look mathematically. Here we have a triangle labeled triangle ABC. In order for me to translate it, I have to slide it somewhere else away from its original point. In this case, I translated it to the 4th quadrant. Now I have 2 images. So therefore, I have to determine which one was my original and which one was the translated figure. In order to do so, we have different notations that we use for each triangle when we label it. If you look closely here, this is triangle ABC. But if you look at this figure, we have A prime. This accent mark we call A prime. So this is triangle A prime, B prime, and C prime. The figure that does not have the primes is called the pre-image, whereas the other figure is now the image. Pre-image is the original figure. The image is the figure that has been transformed, and in this case, translation. It is important to know that you can translate a figure in many directions. You can do what I did and do a horizontal move. Well, it's kind of horizontal and diagonal, but I horizontally translated it to the 4th quadrant. You can also translate it vertically down to the 2nd quadrant, or you can do a diagonal translation to the 3rd quadrant. So as long as you perform a slide, it is known as a translation. Reflections. A reflection is the flipping of an object over a line. That line is known as the line of reflection. This process can also be called a flip. So let's take a look at our example here, real life example. We have a rainbow that is reflecting over the ocean. This will be considered the line of reflection. It's where the reflection and the original image it meets, similar to a mirror. So this is a reflection. Mathematically, if I start with triangle ABC in the 1st quadrant and I want to flip it over our y-axis, I am now left with triangle A prime, B prime, C prime. Now some of you may look at this and say, well, Ms. Arnold, Doesn't that look like a translation? I mean, it could be a slide. The difference is here we have triangle ABC. And if you look at this triangle, it is labeled differently. Here, B is located to the right. I'm sorry, B is located to the left of A, and C is located to the right of A. Whereas if you look at the image with A prime, B prime, and C prime, now C prime is located to the left of A prime, and B prime is located to the right. This indicates that it was flipped over this line. Okay? Now you can also flip over the x-axis. And again, it's indicated by the labeling of our new pre-image. And again, if you have more than one figure on a coordinate plane, you can do double primes to let everyone know that this is a different image or it's been transformed a second time. So if you look at the original ABC, this was flipped over the x-axis, so B is here, C is here, and now A is at the bottom. Reflection. All right, rotations. A rotation is a transformation that is performed by spinning the figure around a fixed point, known as the center of rotation. The figure can be rotated clockwise or it can be rotated counterclockwise. It is also known as a turn. All right, so let's look at this mathematically. Again, starting with our same triangle in the first quadrant, if I wanted to rotate this triangle 90 degrees clockwise, it will end up in the second quadrant. So from here to here, we went 90 degrees, and it's clockwise. Think about a clock. This would be our point or center point of rotation. And if I had hands like a clock coming out, clockwise would be this way. So if I wanted to do 90 degrees, which is just one turn, I'm going from quadrant 1 to quadrant 2, which is 90 degrees. Now, if I wanted to do a 180-degree rotation, my figure would end up in quadrant 3. This is 180 degrees. I am going from this all the way to quadrant 3. So triangle ABC rotated clockwise 180 degrees will place me in the third quadrant. So this is 180 degrees clockwise. And another rotation that we will learn in the 8th grade would be 270-degree rotation. Again, starting with our original figure or our pre-image, if I go all the way around to this area for quadrant, I have went 270 degrees clockwise. And of course, if I were to take it back to its original spot, that is 360 degrees clockwise. So from here to here is 90. From this quadrant to this quadrant will be 180 degrees, and from the original pre-image all the way to the fourth quadrant is 270 degrees. It is the same concept if we go counterclockwise. Counterclockwise is just basically we go in the opposite direction. So to go 90 degrees counterclockwise, if I'm in the first quadrant, I end up in the fourth quadrant. That's a 90-degree angle counterclockwise. To go from quadrant 1 to quadrant 3, that gives me 180 degrees counterclockwise. And then go from quadrant 1 to quadrant 2, that gives me 270 degrees counterclockwise. And again, if we end up here, again, that's 360 degrees, which makes a full circle. And again, our center of rotation would be about the axis. Just like reflections, you can reflect over a certain point as well as rotate around a certain point. But in the 8th grade, we're going to focus our rotations around the origin. The next transformation that we're going to discuss is dilation. Dilation are transformations that enlarge or reduce the size of a figure using a scale factor. And usually we measure that scale factor by less than 1 or greater than 1. Okay? So the scale factor can be less than 1 or greater than 1. And again, a scale factor is just basically when we take an image and we make it larger. Did you see the ball? Did you catch it? I made it larger. And this is easy. So if you look at our original image, this is triangle ABC. I am going to enlarge it. So therefore, triangle ABC has been enlarged to triangle A prime, B prime, C prime. Now, if I wanted to reduce A prime, B prime, C prime, that is still a dilation, and it's being reduced back to its original size, and it can even go smaller. All right, so can you, using your own words, define the following terms? Transformation, translation, reflection, rotation, dilation, image, and pre-image. If you can define all of those terms in your own words and without using your notes, then you have successfully answered the question, what are transformations? Thank you.